Alright, so let's take a look at the section 7.2 additional exercises. So in the first two problems we want to go through and we want to solve the equation. So this is a lot like what we've done before back in the previous chapters. Here I got four terms, so I want to factor by grouping. My first two terms have a common factor of x squared. My leftovers will be a 3x plus 2. My last two terms have a common factor of 16, but I want to pull out a negative 16 since the 48 is negative. And you might be thinking, well, how'd you get that 16? And saying, well, I want this to be a 3x here. So if I take 48 divided by 3, that gives me 16. So that's why I want to take out a negative 16. And now we're going to factor out the 3x plus 2. My leftovers are x squared minus 4. Oh, sorry, my brain jumped ahead. Minus 16. And now that x squared minus 16, we can break that down using a difference of squares into x plus 4 times x plus 4, or x minus 4, excuse me. Can't seem to speak today. My apologies. Alright, so then we go through and set each factor to 0 and solve. So on this one, we're going to subtract 2 from both sides and then divide by 3. That gives me x equals negative 2/3. And then x plus 4 is a factor. My 0 would be negative 4. And if x minus 4 is a factor, then my 0 would be x equals positive 4. So my zeros here are negative 4, negative 2/3, and 4. All right, let's try number 2. And, ooh, this is kind of one of those problems. So let me do a substitution. I'm going to let u equal x squared. So this would be u here and u squared here. So I want to look for factors of 27 that add up to negative 12. Well, they both have to have the same sign, but both of them will be negative. So if I look at 27, I can do negative 1 and negative 27. That gives me a negative 28. That doesn't work. So let's do negative 3 and negative 9. And that does work. And remember, you do that method I showed you on the calculator before. So let me get out of this. Go to your table. Let's clear that. So you're trying to break down 27. So we do 27 divided by x plus x. And then we go to our hit our enter. And we can start this at 1. I want to do this by integers, so I want to step by 1. And see, that gives us 28. 3 and 9, that gives me the 12. Now I want it to be negative, that's why we switch both of these signs. But anyway, you come up, 1 the factor has to be 3. You take 27 divided by 3, that gives you the 9. So this is going to factor into u minus 3 times u minus 9. Well, if we set each of these equal to 0 and solve, you're going to get u equals 3 or u equals 9. But remember what u was, that was our x squared. And now just use your square root property. So from this one, we'll get x is plus or minus the square root of 3. From this one, we're going to get x equals plus or minus square root of 9, which is plus or minus 3. So my zeros are negative 3, negative square root of 3, square root of 3, and 3. I'm just writing them from smallest to largest. Let's try next problem. So I want to determine the end behavior of the graph. So I'm looking for my leading term. There it is. Odd power, so I'm thinking of my x cubed function. No reflection, so my end's got to look like this. So that means as x goes to infinity, f of x has to go to infinity. And as x goes to negative infinity, f of x also has to go to negative infinity. So that's my end behavior. Let's take a look at this next one. That's my leading term. Even, so I think of my parabola. Both ends facing up, but this gives me a reflection across the x-axis, so both my ends are facing down. So as x goes to infinity, f of x goes to negative infinity. And as x goes to negative infinity, my y values also go to negative infinity. Let's take a look at this next one. Ooh, this is kind of nasty. So let's kind of take it piece by piece. Remember, I'm kind of doing my pseudo multiplication here. So if I were to cube this out, if I take 7 to the third power, 343, I would get 343 x cubed plus a bunch of terms. Okay, so now I got a negative 4. I'm going to multiply this with this negative 1 times 343, so this is going to be a huge number. That gives me positive 1372. And let's get the powers here. We have 5, 1, and 3, so that's 9. X to the 9th plus a bunch of other terms. Whew, ay, ay, ay. All right, so my power, excuse me. My power here is going to be odd. That's a huge number. So there's no reflection. So really, 4a is going to be the same as 3a. All right, let's try this next one. So again, I'm going to do my pseudo multiplication. Foil this out. I'm going to have a 4x squared term plus a bunch of other stuff. And let's see where we end up here. I'm going to take a negative 6 times 4 times a negative 1. That's 24. And let's do our powers. X cubed, x squared, and x. That'll give me x to the 6 plus a bunch of other terms. So now, even power, coefficient's positive, so I think of my parabola. My end behavior is doing that. So now I'm going to write this out. As x goes to infinity, my y values go to infinity. And as my x values go to negative infinity, my y values also go to positive infinity. Let's try number 5. We got part A. Find the zeros of function, state the multiplicity. Alright, so we've got a 0, negative 8, and positive 2. Well, C and D are missing 0, so we know it can't be those two. So we have a 0, multiplicity 7, that matches. Well, this is supposed to be a negative 8, so it can't be A, so it's got to be B. 0 multiplicity 7, negative 8 multiplicity 4, that checks. 2 multiplicity 2. So my answer here is B. Let's try this next one. Okay, there's no x with the 14, so we don't count that. So I have a 0 of negative 6 and positive 9. So it looks like it should be C. Let's check it. Multiplicity is 3. Multiplicity is 4. So yes, my answer is C. So we're just using a process of elimination to get to the answer. Alright, so let's look at number 6. Determine if the graph can represent a polynomial function. If so, assume the end behavior and all the term pairs are present on the graph. So we want to determine the minimum degree of the polynomial based on the number of turning points. Determine whether the leading term is positive or negative based on the end behavior and where the degree of the polynomial is even or odd. And then approximate the zeros of the function. Determine if their multiplicity is odd or even. Ooh, that is a mouthful. Okay. So we have 2 turning points, so my minimum degree here is going to be 3. Okay, so let's look at our choices. So A or C. So now we've narrowed. It can't be B, and it can't be D here. So the minimum degree is 3. Okay. Now, think of my x cubed function. It's facing up, so leading coefficient is going to be positive, and the degree is going to be odd because the end behaviors go in the opposite direction. This is facing up. There's no reflection. All right, so let's see if we can narrow it down. So positive degree odd, right? Okay. All right, so this should eliminate C. So my answer choice should be A, but let's double check it. Cross, cross, cross. So each of them has odd multiplicity. So yeah, A is the match. Number 7, we're doing the same thing. So let's count the turning points. 1, 2, 3. I have to add 1, so my minimum degree is going to be 4. Well, that looks like that narrows it down, right? So my answer choice for this last one should be B. Let's check it. Let's see if everything else matches. And if not, we'll fix it so it matches. So then this thing points up, so it should be positive even. So let's fix this. Oh, I'm sorry. Yeah. So let's change this here. This needs to be positive. So there's another typo. So again, hopefully by the time you get the workbook, this will have already been corrected. So my leading term here is positive because this faces up. Degree is even because my parabola, goes in the same direction. So odd multiplicity, even multiplicity. So that matches. So answer should be B with the corrections.